Hello everyone. In this video lecture, we are going to see on topic Bayesian inference from the second unit of artificial intelligence and machine learning. So the objectives of seeing this topic is to understand about the concepts of Bayesian inference and to understand how to apply probability concepts in inferencing. Probabilistic reasoning is a way of knowledge representation where we apply the concept of probability to indicate the uncertain knowledge. In real world, there may be a lot of scenarios we know where the certainty of something is not confirmed, such as it will rain today, behavior of someone for some situations we can't tell about these things. We can't give the confirmations, it is not sure. And who will win in a match? A match between two teams or two players, we can't tell in advance what about the result. In such situations are called as uncertain situations. These informations are called as uncertainty. So in such cases probabilistic reasoning is used. So the need of probabilistic reasoning when there are unpredictable outcomes, when specifications or possibilities of predicates becomes too large to handle, when an unknown error occurs during an experiment. In probabilistic reasoning, we will use one important rule called as Bayes rule. It is otherwise called as Bayesian statistics. And before going to the Bayes rule, we can see some of the basic formulas of probability. Actually, the probability is defined as it is a chance that an uncertain event will occur. It is the numerical measure of the likelihood that an event will occur. The value remains between 0 and 1. So the probability A means it may be some event. Probability of A exists in between 0 to 1. 0 means total uncertainty in an event A. 1 means total certainty in an event A. So the probability of occurrence can be calculated by the ratio of number of desired outcomes divided by total number of outcomes. Also, we can calculate the probability of the negation of the event. Probability of not A is equal to probability of A not happening an event. And another one important thing is probability of not happening the event plus the probability of happening the event will be equal to 1. And another one important thing is conditional probability. So in conditional probability, we will compare two events. We will deal with the probability of two related events. Conditional probability is the probability of occurring an event when another event has already happened. If we want to calculate the event A when event B has already occurred. So the probability of A under the conditions of B, it is called as conditional probability. It can be written as P of A on B. That is, if B has happened, what about the probability of A? Which can be calculated by the formula which is equal to P of A and B divided by P of B. A and B means joint probability of A and B. That is the possibility of occurrence of A and B both together. P of B is the marginal probability. Similarly, we can calculate the probability of P if A has happened. That is, conditional probability of B on A is equal to P of A on B, A and B divided by P of A. And reasoning with the Bayes theorem is called as Bayesian inference or Bayesian reasoning. So it uses the conditional probability and marginal probability of two events. So it is a way to calculate the value of P of A on A with the knowledge of P of A on B. For example, if one disease, cancer, is related with the age of the person, we can determine the probability of cancer more accurately with the help of age. And again, we can consider with the formula P of A and B is equal to P of A on B into P of B. And this in same way we can have with another one conditional probability of the second event. By combining both the formulas, we are getting the conditional probability of A on B, that is P of A on B is equal to P of B on A. into P of A divided by P of B. If we are having these three values, we can calculate the conditional probability of the another event. Here the P of A on B is known as posterior probability, that is the probability we need to calculate. P of B on A, we must have it to calculate the previous one. So it is called as likelihood. P of B, A is called as prior probability. P of B is called as marginal probability. Similarly, if you are dealing with a sequence of events, that is A1, A2, A3 up to AN, it is taken as AI. We can also have the same pattern of formula to calculate the conditional probability of the sequence of events AI. And similarly, if we are considering with the cause and effect, also we can apply the same kind of formula, that is P of cause on effect. And we can see one example, that is what is the probability that a patient has disease meningitis with a stiff neck. And the given data, 80% of the patients having the meningitis will also have the stiff neck. On the whole, totally the probability of a patient having this particular device is 1 out of 30,000. That is 1 out of 30,000 patient is having this disease meningitis. And on the whole, 2% of the patients are having the symptom stiff neck. And our question is, what is the probability that a patient has disease meningitis with the stiff neck? That is, patients, those who are having the disease meningitis, how many patients, those who are having the meningitis, will also have the stiff neck? That is our question. So we can apply the given values, that is P of A on B. A on B is if the patient is having the meningitis device, then what about the probability of patients having the stiff neck? That is 80%. P of B equal to 1 out of 30,000 patients. P of A is equal to 0.02. By applying it is in a conditional probability formula, we are getting some value. When we take the proportion of that value, we are getting 1 by 750. That is, one patient out of 750 patients having meningitis disease with a stiff neck. And we are having some more applications of Bayes theorem in artificial intelligence. It is used to calculate the next step of the robot when the already executed step is given. Bayes theorem is helpful in weather forecasting. It can solve the Monty Hall problem. Thank you.